All right, so during lunch, I said I would go through 3.1, kind of graphing derivatives, graphing functions given a derivative. So here are the questions we went through. So given f of x, sketch the graph of f primed of x. So I don't care that it asked you to graph f primed of x. I still want to see a sign chart. So anytime you're talking about f prime, you really should make a sign chart. And I'll show you one example where I do not make a sign chart. So let's look at this guy. So if I'm looking at, this is actually f of x, but I want to get f prime's sign chart, I should be looking at slopes. So the first question you ask yourself is, where are my slopes equal to 0? So I'm going to put a bunch of points on here just to get an idea of some things. I want to look for where the slopes are 0. So that'd be here, here, and here. I'm going to come down, line it up. Won't be perfect, that's okay, because I didn't scale the graph. That's where the slopes are all 0. There are no undefined slopes. What would an undefined slope look like? Discontinuity, corner, cusp, or vertical tangent. Now, I'm going to ask myself, for the slopes, where are the slopes positive? So slopes positive looks like an increasing f of x. And then slopes negative would be where f of x decreases. So here it increases, and here it increases. So that would be where my slopes are positive. My slopes are negative when the function decreases. That's here and here. So that would be negative here and negative here. So why is that helpful? For some of you, you might not think so, but the helpfulness is the fact that now I can label this and say that f prime being positive means that you're going to be graphing the f prime above the x-axis. This is going to be a 0 on the f prime graph. And then this minus sign is where f prime is negative, and that's where we're below the x-axis. Okay, so we're not talking about slopes anymore. We're talking about the function's y value. So this here, we're really looking, oh, I won't even write that. You'll probably get confused by that. So there we go. So I'm going to graph it in black, I guess. Actually, orange should work. So the zeros, I would have one here, here, right on top of that same point, and here. So that should make sense. The f prime, which is the orange points, right here, f prime is equal to 0. Right here, f prime is equal to 0. Right here, f prime is equal to 0. Remember the pinks? F prime was positive. So in, let's see, what, like a brown color, if I want the f prime to be positive, and I'm graphing f prime, then the y values have to be positive. Now in the green right here, the f prime values are negative. You can see that here. Okay, so that means I'm going to come under, but I have to hit this point again. The pink means that the f primes are positive, but after I get this point, remember that now the green says that the f primes are negative. So that's probably a crappy graph right there, but I'm going to do it one more time. So go down, under, over. All right, so let's kind of investigate what I ended up doing. So I'm going to highlight a piece of the graph right here. That part of the graph corresponds to this negative right here, which corresponds to f prime being negative. So f prime is negative means we graph it below. When you talk about the function, the blue function f of x, if f prime is negative, then f of x decreases. If f prime, meter, if f prime is negative, then f prime is below x-axis. That's where the negative y's are. I'm hoping this kind of clarifies some things. All right, so if you're looking at this graph, so I'm going to ask you to do the same thing. Given f of x, graph f prime of x. So this is the one case in which I don't make a sign chart. So the reason I don't make a sign chart, if you look at this whole arm right here in red, the slope never changes. The slope of that is always 1. How do I get that? Rise 1 over 1. Rise 1 over 1. If I look at the middle in pink, the slope here never changes. It's always 0. And then at the end here in orange, The slope here never changes. The slope is down 3 over 1. Down 3 over 1, so the slope is negative 3. What that means is now that if I want to graph the derivative, I really am taking the function and graphing, and I'll do this in pretty dark blue. Then I'm going to graph a slope of 1 until I get to x equal to 1. The derivative doesn't exist because it's a corner. And then from x equal to 1 to x equal to 4, the slope is 0. And then the slope after that is negative 3, so it's constant. If you look at most curves, I ask you to graph the derivative of this, the slope changes. Every single time I kind of move up the curve, if I ask you to draw your tangent lines, they all look different. Why would I ask you to do that? Because that would be how you find the slope. But if I ask you to draw a tangent line at anywhere on this graph here, they're always the same. They always look exactly like the curve. Okay? I'm going to take that piece away. I don't want that on my graph. All right. Then last piece, number 14. I think there might be a 15. Given f of x, make a f prime sign chart. So given f of x, you're trying to get to f prime. So really, you're looking at y value. So how do you make the sign chart? You first make your signs. Okay. These marks here would be when the slope is equal to 0 or undefined. So what do they look like? 0 slopes are things like this. Those would be 0 slopes. Undefined would be things like corners, or a cusp, or a vertical tangent. Okay, that's not a vertical tangent. Or a discontinuity. Okay? So that's what I first do on these lines, and I would put either zeros or undefined. Next, if I'm trying to get from, I made a huge mistake. So I was given f prime to make the sign chart. I'm going from f of x to f prime of x. Shouldn't say y values because it says slope. So I'm looking at the slope, which is why I have this word here. So now, if I want to get a plus sign on my sign chart, and I'm given, remember, I'm given f of x, I'm not given the actual f primed of x graph. A plus sign would be where the graph, f of x, increases, and a negative sign would be where f of x decreases. Now, it's slightly different if I say, never mind, given f primed of x, make f primed of x sign chart. Well, this one's a little bit easier. F prime to f prime means it's the same function, so you're really looking at y values. So you're just asking yourself, where do you have y values equal to 0? And where do you have y values that are positive? And where do you have y values that are negative? So we're looking for when y values are 0 or undefined. You're then going to look for where y values are positive, which means above the x-axis, and then where y values are negative will be below the x-axis. Different from when your slope is positive, tells you that the function increases. Where your slope is negative, the function decreases. Last piece, number 15. Given the derivative, graph the function. So the derivative is given here, and that's supposed to actually have a prime mark. What that tells me is I'm going to start with the point. And f of 3 is 2. There's my point. Because that point is in the right side of the function, I'm going to just continue on with the slope of negative 2, which would be down 2 over 1, down 2 over 1, down 2 over 1. So I would just continue till I'm off this grid. And that would be to the right of x equal to 3. Now the problem is going to be at x equal to 1. So I'm actually going to go backwards in pink, left 1, up 2 over 1, up 2 over 1. So what that does is does the slope just backwards. And I'm going to connect it back. Now, once I get to the x value of 1, I'm going to now go to the left of 1, so my slope has to be a positive 1. Slope of positive 1 would be rise 1 over 1. Backwards would be down 1, left 1, down 1, left 1, down 1, left 1, and so on. So these would be the points that I would have to connect to create that part of the line. So what did we figure out? If you look at the left side, the slope is 1. If you look at the right side, the slope is negative 2. If you look at here, that's a corner. What does that mean? The y value at 1, it exists. It's 1, 2, 3, 4, 5, 6. But f prime of 1 does not exist because it's a corner. Alright, 1, 6. There we go. That should be everything. I believe that's the last page of the review.